When you submit your final design, you will include a proposal. An engineer's written proposal explains to others how and why a design solution works. While scientific arguments and engineering proposals are different in some ways, both use evidence and reasoning to support a claim. In an engineering proposal, your claim describes why you think your design is optimal. We talked a little bit about that word yesterday. I wanted to give you a little bit of advice, and so the first thing I want to tell you is this. Whenever you're trying to communicate scientific ideas, it's important to remember who you are trying to convey this information to. This audience reading this proposal most likely understands less about tsunamis and warning systems than you do at this point, and you're trying to convince them that your design is optimal. You need to consider which types of evidence would be the most important to include. So after you have tested and retested your design, you feel like you've got a pretty good design, and then you're going to open up your future workspace, and you'll find in your inbox a form that says proposal outline. This is probably one of 3 or 4 things that are in your inbox. Your screen is going to look slightly different than mine. And so what you'll notice, the first thing is that it asks you for the same things that I asked you for in the tsunami warning system, which is just called Tsunami Alert Design. And after you submitted that, Hannah Wong gave you back some information. So let's look at this. It's going to ask you for, hold on a second, which version you're using, how many earthquake sensors you have, what their coordinates are, any shallow sensors and what their coordinates are, deep sensors and their coordinates. And so at that point, things are pretty similar. But then the second part of this form asks you for all of your design decisions. It asks you for your comparisons to other designs. And then it also asks you for any background information or background research for each one of those things. So I'm going to give you an example, and you can use this to kind of help you form your own. After you turn this in, I'll be looking over it over the weekend and contacting you if I have any questions. And on Monday, we'll begin our actual proposal, which will be using this outline to present a written with paragraphs and that kind of thing. I'll give you more help with that on Monday. Don't worry about that now. For now, the most important thing is filling in this form after you test and retest your design. Okay, so here's an example. And remember that as you're writing your proposal, here's a couple of last-minute pieces of information that might be helpful. Focus on your proposal sections one at a time, and then use the outline to kind of have some key ideas for design decisions. I have a rubric that is posted on the Schoology page that you can take a look at. It's also on your future workspace. So the first one asks you for some background information on your, let's check to make sure. I think it's, oops. Thanks for waiting with me on that. The first one talks about average warning time, and it asks for your design goal. Then it talks about the background research for your average warning time. So here's an example of that. This is just written from a different design. It will be very different than yours, but it just kind of gives you some sense of what you could be writing. Any of these statements here could be helpful. They're just the reasons that you chose to put your sensors where you did. Some could include things like how much time you were getting, if you were getting the necessary warnings. And then these statements are something that you can show that you really understand about plate motion. So for instance, things like earthquakes along transform and divergent boundaries don't cause tsunamis, so I didn't put any sensors near those kinds of boundaries. Or something like, we need enough sensors sending data for all warnings, like 2 shallow or 1 deep and 1 earthquake, because at this point you realize in order for a warning to be sent, you really need to have more than 1 sensor. And then after those both trigger, then that's going to send a warning. You could say things like, you place the shallow earthquake sensors along the convergent boundaries, since that's where the earthquakes that cause tsunamis are likely to occur. This one just talks about how shallow sensors give the shortest warning time because they have a long delay. This could be the reasons why you chose that. The next part is going to ask you about false alarms. So you can fill in the form by explaining, what your choices were for that. And then there's this form that One of the boxes asks you to compare it to other designs, so you should compare it to other designs that you had. And then it's going to, again, ask you for background research. You could say things like, earthquake sensors give false alarms for earthquakes over 7.0. Shallow sensors give false alarms for local tsunamis. Some sensors placed near convergent boundaries might break and avoid sending data for false alarms. And another thing could be something about earthquakes on divergent and transform boundaries that cause earthquakes over 7.0 could cause false alarms. So no sensors are needed there because those aren't going to cause tsunamis. And so if you have an earthquake sensor there, it might give a warning, but it's not going to cause a tsunami. So that would be just the background research of why you chose to place your things in the way you did to avoid false alarms, which is one of the criteria for this design. The last part is going to be talking about the total 50-year cost. Again, this is the third and final criteria. It's a chance for you to compare it with other designs that you had, and this is where the trade-offs that you were talking about in the form you filled in yesterday are really going to be helpful. So please pull the form out as you're filling in the data on the future workspace. Here is some background information, example background information for the choice of the cost and how you kept the cost down for that criteria. Something like deep sensors are very expensive, and so in this design, I chose to use more shallow sensors. However, deep sensors are also very helpful, so if your design includes a lot of deep sensors, that's also okay. Another thing could be placing sensors too close to boundaries with strong earthquakes, cause them to break. I think a lot of you noticed that you were breaking your sensors if that was happening, so be talking a little bit about how you tried to avoid that in your cost analysis. Okay, let's take a look at this thing one more time. When you are finished filling in all of these different boxes, then you'll go ahead and submit that to Hannah Wong, which I will see, and then I will give you some feedback so that you can use that when you're writing your final proposal, which is for a summative grade on Monday. All right, good luck.